Bismillahirrahmanirrahim. I have decided to record the lectures, so you will have the advantage to listen my voice and listen my explanation about the lecture. So I am going to upload these lectures, and you will have the link to view and listen these lecture from the website. So today we are going to start and discuss the lecture number 5. This lecture is about the prototyping. In this lecture we are going to discuss about the various issue about the prototyping. As we have learned earlier that when we are designing a project, then we have to create the prototype, so the user or the customer shall have some idea from the prototype that either it's going to meet the requirement or not, because as we know that requirement is one of the most important stage in the software design, and if there is some problem in the requirement, later it is quite expensive to correct the mistakes. So it is better that we have a prototype, and we can move forward once the prototype is satisfying the customer requirement. So let's see that what are the content for this lecture. We are going to discuss about the prototyping in general, then the conceptual design. In the conceptual design we are going to discuss about that when we are going to design a new product, then what concepts are there to interact with the system, what kind of interfaces are there, what kind of interaction types are being used in the design. We are going to discuss about the concrete design and using scenarios and generating the prototype. In the prototype we are going to discuss some classification or the categories of the prototype. Some of the prototypes are more in detail, and some of the prototypes are not in detail, but they are covering the more aspects, in the sense that rather than describing a function in detail, we are describing more functions. And then finally we are going to discuss about the constructions of the prototype. So first thing is that what is a prototype and why the prototype is important. We will discuss about the different kind of prototype, low fidelity prototype and the high fidelity prototype. Basically in the low fidelity and the high fidelity prototype, we are discussing that what kind of material is being used to construct the prototype. Sometimes we are using the material in the prototype which is going to be used in the final product. So we can say this is like a high fidelity, and sometimes we are using the different material which is a low cost, so it is called a low fidelity prototype. We'll discuss some features and advantage for each of these. And then there are some compromise in the prototyping, that how much detail we are covering in the prototype. So two categories are there in the compromises, one is the vertical and one is the horizontal. We are going to discuss more detail about this thing. And final product need to be engineered. Need to be engineered means that based on the prototype we have to create the final product, because the prototype is not the final product. So the first question is that what is a prototype? In other design field, a prototype is a small scale model. So whatever we are constructing, we are creating the small scale model for this thing. For example, if we are going to manufacture a car, then a miniature car is going to be the prototype, which is a small scale or very small car is there. If we are creating some other thing, for example some artifacts, then a prototype is going to be the small model for this thing. And in the field of civil engineering, if there is going to be a building, then a miniature building is going to be the prototype. This can be made from the plastic or from the wood, so the users or the customers can see and can get the idea about the prototype. Here you can see that on the right side we have a picture, and this picture is being actually the is of being manufactured a kind of design, a kind of machinery from the 3D printer. So nowadays a 3D printer are getting popular, so we can create the prototype using the 3D printer because it is much more sophisticated. We can feed the design into the computer by using the software, and the 3D printer is going to print out the prototype. Of course, this is not using the actual material which is going to be using the final product. This is using some other material, of course, which is the less cost, and this is going to be the small scale model for this thing. So let me try to show you a video. So here we have the videos are there. So let's see affordable desktop 3D printers. So here you can see that in the design field the 3D printers can play an important role. We can construct the prototype of the different product by using the 3D printer. Of course, software is required there which is going to create the model, and once the model is there, the 3D printer can give the printout in the 3-dimensional for this printer. And the material which is going to be used in the 3D printers is something which can be molded and which can have the property to be deformed in the different shapes. So, and you can see that the 3D printer is in work, and they are printing a product.
If you just want to fix something around the house, it will do that.
So there are some knobs are there, some controllers are there. We can take the measurement of these things, and by these measurement we can construct a design using the software.
It doesn't matter if you're a professional 3D designer or whether you're somebody who just has an interest. The UP 3D printer can be used by anybody.
So even the people who are not very expert, they can use the software and they can design the product.
Put it together really quickly and save you a lot of time.
So some fixing and some adjustments are required there, and once these adjustments are made, we can use the printer for printing purpose. So let me move a little bit quicker. I am forwarding this. So then in the software we are providing some options, some settings. You can see that this is a model of a 3D cube, and with the cylinders are there in the middle. So the 3D printer can be used to print out this model. So you can see here in this picture that different objects are being printed in the using the 3D printer. So even the small scale models can be created, and then we can print out these using the 3D printers. So the purpose is that to show you that we have better technologies, and we have a way to create the prototype by using the 3D printer. Let's come back to the slides. Now let's come to the topic. What is a prototype? In interaction design, the prototype can be a series of sketches. In the previous slide I show you that a sophisticated 3D printer which can be used to make a prototype, but it's not necessary that always we have such a sophisticated or advanced technology. A simple series of the screen sketches can be used as a prototype, or a storyboard, that is a cartoon like series of the scene, can be used to create a design. Because if we are imaging a situation, then it is better that we create the sketches, and then based on these sketches we can progress in the design. Or the prototype can be a PowerPoint slideshow. As you can see that I am running this PowerPoint slideshow, so this is a kind of prototype. A video simulating the use of a system. So in order to train the people, we can use the video as a prototype, so the people can see the video how to use the system, then based on this video they can use the actual system. So in that case, video is something like a prototype. It can be a recorded video, or it can be a animation video, or a cardboard mockup can be the prototype. We can construct some physical modeling using the cardboard. Of course this is not using the actual material, but cheap or less costly material can be used to create the prototype. Or a piece of software with the limited functionality. If you are talking about the softwares, then rather than making or constructing or building the complete software, we can use some prototype applications to build a model which is just showing the, for example, like a graphical user interface of the complete system, but the functions behind these interfaces are not there. For example, the user can see the buttons, user can see the icon, the list, the combo box, the radio boxes. So the user will have the idea that what kind of interfaces and interaction types are there, but the functions either are not present or they will have the limited functionality. So this can be a prototype. So we know that the prototypes are there in the different forms. Now the question is that why the prototypes are important. Evaluation, the feedback are central to the interaction design. So we have to evaluate, we have to know that either we are going in the right direction or not. So the prototype are helping us to evaluate our work. And the second thing is that the prototypes are helping to get the feedback from the user or from the client. So by looking at the prototype, by looking at the interfaces, by looking at the model, the customer can give us the feedback to the designers that they are going in the right direction or not. Stakeholder, which are the final user, can see, hold, interact with the prototype more easily than a document or a drawing. So if they can hold the prototype, they can hold the model, they will have the better idea rather than just reading some documentation or looking at some drawing. Another advantage for the prototype is that the designer team can communicate effectively. Once they have a prototype, they can see the prototype, they can touch it, and they can discuss the idea, they can discuss the alternative by using the prototype. And you can test out idea for yourself. So even if the team members are not there, by the prototype you will have the chance, or you have the ability to discuss the idea. Prototype answer questions and support designer in choosing between the alternative. So prototype is helping the designers that they can evaluate the multiple solution which are the alternatives are there, and they can decide that which solution is going to meet the requirement of the system. So we can see here that there are the numerous advantages are there for the prototype. Now let's talk about the filtering dimension of the prototyping. What mean by the filtering dimension? The filtering dimension means that how we can classify or how we can categorize the prototype. So there are the multiple filtering dimensions are there. For example, we can do the filtration of the prototype based on their appearance. For example, their size, small or the big or the medium, or we can do the filtration based on their color in the category appearance, or based on the shape or the margin, or the forms, weight, texture, proportion, because the different material will have the different kind of texture of a wood, texture of a plastic, and of course the weight and the size are somewhat related. We can categorize the prototype based on this thing. The proportion means that what are the different, how the different dimensions are being have the relationship with each other. And the hardness, transparency, gradation, haptic, and sound. Haptic means that something where the user get the feedback in terms of some vibration or some other thing which the user can feel. So this is one of the filtering dimension for the prototype. Another dimension for the prototype is the data. For example, we can categorize the prototype based on the data size. Some will require that the small size data, some will require the big data, or we can make a classification based on the data type, because some system require only the numbers, some system require the numbers and the string or the text, and some system require the media data, which can be images or the pictures. Or we can do the categorization or the filtering based on the data usage or the privacy type, because in some of the system the different user will have the different privileges, they will have the different level of the privacy. Or we can categorize or filter the prototype based on their hierarchy. So in such cases, some classes or some categories at the higher level, and there are some classes or some types are at the lower level. So a kind of sub and parent class relationships are there, or based on some other organization factors. So these are the two filtering dimensions for the prototype. Similarly, there can be the other filtering dimension for the prototype. For example, based on the functionality, what kind of functions the system is performing. So two different systems can be categorized based on their functions. Or the interactivity, for example, what kind of input behavior is there, what kind of output behavior is there. For example, in some of the system we can say that their input is the touch base, and some of the system their input is by some mechanical means or by some sensor. And similarly from the output, that some of the systems are providing the output on the screen, or some maybe on the paper, like this thing. And how they are providing the feedback to the user, and what information behavior is there for the different prototypes. So again, this is a kind of categorization of the prototype. Or we can do the classification of the prototype based on the spatial structure. What I mean by the spatial structure? Spatial structure means arrangement of the interface or the information element. For example, one possible way is that we have a two-dimensional structure in which we have the rows and the columns are there. Or sometimes we have a three-dimensional structure in which we have also the depth. So we can have a three-dimensional spatial structures are there. Or sometimes we can filter the prototype based on that they are the tangible, or they are not tangible, or they are intangible. Tangible means that something which can be touched, so the user can touch the material and they can feel it. But some of the things they are not touchable. For example, if we say that the hard copy is a tangible thing, but a soft copy or the application itself is not a tangible thing. So these are the filtering dimension of the prototype. Now let's talk about the manifestation dimension of the prototype. So what is the manifestation dimension? Manifestation dimensions are the categories of aspect of how prototypes are implemented related to the final artifact. So sometimes it is possible that we are creating the prototype by using the same material as the final product will be. For example, if we are creating a prototype using the Java programming language, and our final product is also using the Java programming, so we can say that they are using the same kind of material. But sometimes it is not the possible. The material are different for the prototype. Maybe this is like a cardboard or a plastic, and the final material is different. And the dimensions can talk about the material, as I told you that sometimes the same material as the original and the final, and sometimes different. Or the dimension can be the resolution. The resolution means that the prototype can have a lower resolution, or you can say that a kind of lower quality, but the final product is going to be the higher quality. For example, if we are going to create a logo or the picture, then the final picture will have the very high resolution, but initially we can create the low resolution, or based on the scope of the subject or the scope of the final product, we are using at the same scope or we are using the different scope. So each compromise a number of variables determined for the individual analysis. So manifesting dimensions are have the different variables are there. We can use the variable like a material, or we can use the resolution, or we can use other than these things as a manifesting dimension of the prototype. Now let's discuss some example for these manifesting dimension. For example, let's come to the material. Medium, either visible or invisible, used to form a prototype. For example, the physical media, paper or the wood and a plastic. So these are the visible materials are there. We are constructing the prototype using the physical media. Tools for manipulating the physical material matters, for example, knife, scissor, pen and sandpaper. So there are some tools are there which are being used to cut the paper or to cut the wood. So they are like a material which are the manifesting dimension of the prototype. Or the computational prototype, in which we can say that they are not something like visible. For example, if we are using the software which is called the Macromedia Flash, it is being owned by the Adobe, or the Visual Basic, so they are like a software, so which are not visible, so their material is not visible. So they either they can be the visible or they cannot be the visible. But I also told you that, for example, if we are creating the prototype using the paper, but the final product may not be construct of the paper, it may be of some other material. And now the next manifesting dimension of the prototype is the resolution, level of detail or the sophistication of what is manifested corresponding to the fidelity. So how much detail we are providing. For example, in the thumbnail image we are providing the less detail, number of pixels are very small, but in the final image the image size can be very big, or the resolution can be very high. So basically this is the accuracy of performance, that is the feedback time responding to input by user. Giving user feedback on a paper prototype is slower than a computer based one. Appearance detail, interactivity detail, realistic versus the fake data. So different kind of resolutions can be used in terms of the pixel, in terms of the other thing. For example, some prototype can have a lower kind of giving the lower feedback or the slower feedback, but some actual product may have a higher feedback. Or the manifesting dimension can be the scope, the range of what is covered to be manifested. For example, the level of contextualization. For example, website color scheme testing with only color scheme chart or color scheme placed in a website layout structure. So when we are creating the website, we will have the different options. For example, there can be some given scheme can be there. So all the colors are based on this scheme, but sometimes it's possible for the user to change this scheme and select some other scheme. So the scope can be different for these things. With only one color scheme, charts or color scheme placed in website layout structure. Book search, navigation, usability testing with only the book search related interface or the whole navigation interface. So if in a library we are creating a prototype, then in the prototype there might be the possibilities that we can search only the book. So the scope is the limited, but alternatively there can be the other option in the search which can be performed in the prototype. So in that case the scope is going to be the bigger one. Now the next question is that what to prototype. There are some technical issues are there that can be prototype. The workflow or the task design can be prototype. Screen layout and the information display can be prototype. Difficult or the controversial or the critical areas can be prototype. So all of these things are the possibilities that they can be prototype. So depending on the design, depending on the problem space, we can make a prototype. Now let's see categorization of the prototype based on this thing, that what kind of medium we are using. So one is the low fidelity prototyping and another is the high fidelity prototyping. So in case for the low fidelity prototyping, we are using a medium which is unlike the final medium. So for example, if we are using the cardboard or the plastic to construct the prototype, but the final product is made of like a cement or like some other material, then we are going to say that this is a low fidelity prototyping, because we are using other material which is not like the final product. This material can be the paper, this can be the cardboard, this can be the plastic or anything. It's quick, cheap and easily changed. We are using these material in the prototyping because they are not very expensive and we can easily modify them, we can easily change them. For example, some of the prototypes using the low fidelity are sketches of screen, task sequence, extra. Either we can draw the sketches on the paper or we can use some software to draw the sketches. We can easily modify, we can easily change these sketches, or sometimes we can just put the notes on the sticky paper to create the prototype to get the idea about the design. Or this can be the storyboard in which we are going to describe a situation, how the user is going to interact with the system. So this can be described by the cards or by the sequence of the sketches or the images, or a technique which is called the Wizard of the Oz. We are going to discuss a little bit more about this technique in which a person is interacting with the computer and he don't know that either it is a human or the computer. The next category is the high fidelity prototyping. So if you have idea about the low fidelity prototyping, intuitively you will get the idea about the high fidelity prototyping. So in the high fidelity prototyping, we use the material that expect to be in the final product. As I give you the example, that if we are constructing the prototype using the Java programming and the final software is also using a Java programming, then this is the high fidelity prototyping, because we are using the same material which is, or the same software which is going to be in the final product. Prototype looks more like the final system than the low fidelity version, so this can be the advantage for this high fidelity prototyping. High fidelity prototype can be developed by integrating existing hardware and the software components. Since we are using the same material, so we can integrate the existing components and to build the prototype. But there can be some disadvantage for the high fidelity prototyping, which is that this danger the user think they have a complete system. Since the user is looking at the prototype, and since we have used the same material like it is going to be in the final product, user might think that this is a complete system, but actually this is not the complete working system, this is just the prototype. So this can be the disadvantage for the high fidelity prototyping. Now we are making a comparison between the low fidelity prototype and the high fidelity prototype in our table. So in the low fidelity prototype we have some advantages and we have some disadvantages. Similarly, for the high fidelity prototype, there are some advantages are there, there are some disadvantages are there. So for the low fidelity prototyping, advantages are there: lower development cost, evaluate the multiple design concept, useful communication device, address the screen layout issues, used for identifying the market requirement, proof of the concept. Disadvantages are there: limited error checking, because we are not using the actual material, so error checking might not be possible. Poor detailed specification to code to, so specifications are not very clear which can be used to write the code. Or facilitator driven, limited utility after the requirement established. So the material is not the same as the final product, so even the user or the client is satisfied, we cannot use the prototype to build the actual model. Actual model have to be built from the scratch because they is not using the same material. Limited usefulness for the usability test, because they are not providing the actual things, actual material, so they cannot be used for the usability testing. And the navigational and the flow limitations are there. In case for the high fidelity prototype, things are going to be a little bit reverse for this thing. For example, complete functionality is there, fully interactive, user driven, clearly define the navigational scheme, how we are moving from one screen to the other, what buttons are there, what navigation schemes are there. Use for exploration and test. So because this is something like a actual product, so we can give the prototype to the final user and he can press the button or he can touch the product, he can use the interfaces to evaluate the product. Look and feel of the final product, because once the user is holding or using the prototype which is being made of the same material as the actual or the final product, he will have the look and feel idea about the product. So this is the advantage for this thing. Serve as a living specification, marketing and the sales tool. So the company or the designer can use this high fidelity prototype for the marketing purpose. They can show to the customer and get the contracts about this. But there are some disadvantages are there for the high fidelity prototyping. More resource intensive to develop, more resources are required there. We are using the actual material which can be costly. Time consuming to create, of course we have to spend more time. We are not using simply paper or something like this thing. Inefficient for the proof of concept design. So this is not very efficient for the proof of the concept design, because the concepts are something which are based on the theoretical framework. Not effective for requirement gathering. So usually they might not be very effective for the requirement gathering. For the requirement we must have to contact with the customer, we have to do the surveys, questionnaire, interviews to get the complete requirement. Just building a prototype might not be sufficient for the requirement collection. Now let's talk about the prototype. Let's talk about some technique which are going to use for the building the prototype. The first is the storyboard. A storyboard is a graphic organizer that consists of the illustration or the images. Illustration means we are drawing something by using the paper or the pencil or by using the software. Displayed in a sequence, so we have to display them in the sequence. So we are creating something like a story, that this is the first image, this is the second image, from the first we move to the second, from the second we move to the third. So they are like a sequence of the illustration for the purpose of pre-visualizing the video or the animation. So if we have to create the animation, so rather than directly creating the animation on the software, it's better that we create the storyboard and we draw the series of the sketches on the paper, in which the actors are performing some action in a sequence, and then once this storyboard is being constructed and we have satisfied with this thing, we can develop the final product. It is a series of sketches showing how a user might progress through a task using the device. So if the user want to use the device, there might be some steps can be there, there can be some sequences there. First the user maybe have to log in, and then the user have to go to certain tab, then fill out some detail, and then maybe press the like a submit button. So we can demonstrate or we can create the sketches to show these steps. So maybe one step is being shown by one sketch or one picture, or sometime more sketches can be required to show the step. So storyboard are often used with the scenarios, bringing more detail and chance to the role play. So sometime we are also using the storyboard with the scenarios, in which we have to describe the different situation by which the user interacting with the system. So as I say that, for example, if we are logging to the system, now the logging to the system can be in a different way. For example, one login is for the student, another login is for the faculty member, one is for the guest user and one is for the administrator. So different scenarios can be there, so the storyboard can be used with the scenarios also. And storyboards are basically or mostly used in the early stages of the design. So let's see some sketches here. Sketching is important to the low fidelity prototyping. So here you can see that we are creating the sequence of the images, and this is a storyboard depicting how to fill a car with the gas. So if someone has to fill his or her car with the gas, then he or she has to follow these steps. In the step number 1 or in the sketch number 1, drive the car to the gas pump. Step number 2, take the nozzle from the pump, which is you can see that he is taking the nozzle from the pump. Sketch number 3 says that and put it into the car gas tank. So the user have to put the nozzle of the pump into the car gas tank, and then squeeze the trigger on the nozzle until the tank is full. Replace the nozzle when the tank is full. So he has to put back the nozzle on the pump and pay to the cashier. So we can depict the situation by the series of the sketches. So once we understand the situation, once we understand the drawing, we can construct the complete model for this thing. Don't be in habit about the drawing ability, practice simple symbols. So once you are using this technique for the sketching, don't think that you need to be a master or you need to be an artist to draw these sketches. Even you are the beginner and your drawing skills are not very good, but just use the simple symbols to draw these sketches. And even you can use some software, because many software provide the templates to draw the sketches, in which we can use the standard symbol to show the flow chart of the system. The next technique for creating the prototype is the card based prototype. So rather than directly drawing on the papers, we can use some card of the standard sizes, and we can show the action, or we can show the illustration on these cards. So usually the card which are used are the index card, which are of the size 3 by 5 inches, and each card represent one screen or the part of the screen. So we can say that, for example, this is the screen 1 and this is the screen 2. So each screen can be built on the separate card, or the multiple card can be used to build a single screen. And often they are used in the website development. Usually in the website development we have the different pages are there. So each page can be prototype on the card, and of course there should be some navigational mechanism, how the user is moving from one page to the other page, and how it is going to go back to the home page, and how it's going to jump from page not in a sequence, but in a random way. So but the card based prototyping are used in the website development. As I told you that there is a technique which is called the Wizard of the Oz prototyping. Let's see that what is the Wizard of the Oz prototyping. In this picture you can see that there is a user is there, and the user is interacting by some person or by some system, but the user actually don't know that this is a person or this is a computer. He is just interacting with this thing. The user think they are interacting with a computer, but a developer is responding to output rather than the system. So the user is thinking that he is interacting with the actual system, but actually actual system is not there, because this is just a prototype. So a person is responding to the answer of the user. So the user will have the idea that how the system is going to behave in the final product. But of course in this case we need a person which is able to answer of the questions what is going to be answered in the final product by the system, and usually done early in the design to understand the user expectation. So user are typing some questions and they are being answered by the person, which are in the final product are going to be answered by the system. What is wrong with this approach? So what can be wrong with this approach? As I told you that there can be some misunderstanding, or the user may have a higher expectations, and if this person is using the intelligence which is not available to the final system, then the final system cannot behave according to the expectation of the users. Now let's talk about the compromising in the prototyping. Compromising means that we cannot build the prototype which is going to fulfill the requirement of the final product. There are going to be some kind of lacking in the prototype and in the final product. All prototype involve the compromises. For software based prototyping, maybe there is a slow response, sketchy icon, limited functionality. So if you are creating the prototype for the software, then the prototype response time can be just slow, the final product can behave fastly. So this is like a compromise. Now let's make some categorization for the compromises. One is called the horizontal compromise, other is called the vertical compromise. Horizontal compromise provide a wide range of function but with a little detail. So if we are constructing the prototype with the horizontal compromise, then we are trying to provide the range of function. Many functions are there, but these functions are not actually fully functional. They are not doing the complete job, just they are being shown there, but details are not there for these functions. They are not completely implemented. Sorry. The vertical compromise means that we are providing a function with a lot of details are there. So you can say that the function is maybe working fully, but we are providing the very few functions. So rather than providing a lot of functions, we are just providing very few functions, but they are provided in the details. So this is called the vertical compromise. Compromising the prototype must not be ignored. Product needs engineering. So in the final product, you have to be careful that you have to not compromising the final product. This is only during the prototyping. Now let's talk about the conceptual design. So after the prototyping, we have to design completely that how the system is going to be work finally. A conceptual model is an outline of what the people can do with the product and what concepts are needed to understand and interact with it. So in the conceptual design, we have to understand that how the user is going to use the final product and how the user is going to interact with the system. What are the steps are there, and what are the interfaces types are there, what are the interaction types are there. We have to clarify this thing during the conceptual design. So the conceptual design transforms the user requirement needs into the conceptual model. And in this stage we have to consider the alternative, and the prototyping is helping us that what is the most suitable conceptual design for the final product. We have discussed previously about the metaphor. Metaphor means that we are trying to explain the system with the existing knowledge. So the user have the existing knowledge about something, and user is familiar with that knowledge, and then we can use this knowledge to build a system, a new system. So the user can use the existing knowledge to use the new system. For example, like online shopping is based on the metaphor of the real life shopping. So in the real life shopping, we are using the shopping cart, we are paying by the credit card, we put the product in the cart, then we go to the cashier or the counter, and then we pay this thing. So the similar concepts are used in the online shopping. So these are metaphor being used there to design the online shopping. Interface metaphor combine the familiar knowledge with the new knowledge in a way that helps the user to understand the product. So we can use this thing to build the conceptual model of the product. 3 steps are there: understanding the functionality, identify the potential problem area, and generate the metaphor. So in the conceptual design, we have to understand the functionality of the system, what might be the problem area, and how we can generate the metaphor to build the system. Evaluating of the metaphor, how much structure does it provide. So if we are using the metaphor, so we have to evaluate that either this metaphor is suitable or not. How much is related to the problem. So sometimes it's possible that the metaphor is related to the product, but sometimes there need to be some modification in the metaphor, how the users are using something with the existing knowledge, but they may not be exactly applied to the design of the new product. Is it easy to represent? Will the audience understand it or not? So these questions have to be answered during the prototyping. And how extensible it is, because sometimes we need the modification, we have to enhance the functionality. So if we are using some metaphor, we does not have this capability, then the user might find it difficult to use the actual system. Considering the interaction and the interfaces type. So there are the different interaction types are there are the different interface types are there. So we have to consider that which one is more suitable for the system we are developing. As we have learned in one of the previous lecture, that there are the 4 interaction types are there: instructing, which is something like giving the command; conversing, which is something like talking with the system; manipulating, which is by some keys or some controllers we are manipulating by using the mouse or by using the gaming controller; or exploring, in which is something like going into the system or into the virtual world. So for the conceptual design, we have to decide that what interaction types are going to be used to build the system, maybe one or maybe more than one. Do the different interface type provide the insight or not? Now after the interaction type we have to see that what interface we are using. So some interface can be the shareable, where the user can share the interaction space. Maybe some board is there, some electronic boards are there where the multiple user can use the board at the same time. Or the interface can be the tangible, where the user can feel and can touch it, or it can be some augmented reality can be there. So the one or more than one interfaces can be used to develop the system based on some interaction type. Expanding the initial conceptual model, what function will the product perform? So we have to answer this question, that what function will the product is going to be perform, what will the product do, and what will the human do. Task allocation. So sometimes we have to allocate them, that these things have to be performed by the user. This may be something like an input, and these things have to be performed by the system. So we have to make a separation between them. How are the functions related to each other? So what are the relationship between the functions? Either the functions are working in the sequential. Once we complete the one function, then the output of the one function is going into the input of the other function. So they are working like a sequential. Or is it possible that the multiple function can work separately? So they are working like a parallel. Or we can make a categorization of the function actions related to the privacy on a smartphone. So the function which are related to the privacy, we can make a category of these functions. They are being related because they are being related to the privacy. So there can be a different categorization of the function in the conceptual model. What information is needed? What data is required to perform a task? Maybe we have to give some numbers, some text, some images, or something like this thing. How is this data to be transformed by the system? So what kind of functions are there, and how these functions are processing the data? Maybe we are sorting the data, we are searching the data. So in the conceptual model we have to decide the job of these functions, how they are operating on the data. Now after the conceptual design, let's talk about the concrete design. Many expect to concrete design. For example, what color we are using, what are the icons are there, what buttons are there, radio button, check boxes, what are the interaction devices are there we are using, maybe the keyboard, the mouse, or some other devices are there. The user characteristic and the context. So what are the characteristics of the final users and in which context they are using? There are some accessibility issues are there, some cross-culture design issues are there. Maybe we have to think about the support of the multiple languages, or the date maybe in the Hijri and in the other calendars. Culture web guidelines. So if you are designing the website which are going to be used people from the multiple cultures, then note these points. Successful products are bundle of the social solution. So we are humans are the social animals. So if you are providing them a product which is solving their social problems, then this is going to be the successful. Inventors succeed in a particular culture because they understand the values, institutional arrangement, and the economic notion of the culture. So it is very important that if you are building the product, if you are designing some product, you have to understand the context, you have to understand the culture, you have to understand the problems of the people, and then you are going to provide the solution for these problems according to their cultures. Now let's talk about the using the scenarios. A scenario is an idealized but detailed description of a specific instance of the human-computer interaction. So a person or a user can interact with the computer in the multiple instances. So a scenario is specifying the specific instance. As I told you that a user can interact with the system as a guest login, or maybe it can be like administrator login. So these are the different scenarios are there, how they are going to be proceed and how they are going to be work. Use throughout the design in the various ways. So in the design you have to use the scenarios, multiple scenarios are there, we have to use them in the design as a basis for the overall design. Script for the user evaluation of the prototype. Concrete example of the task. So if the user is providing the task, the user are doing the task, so for each task we have to create the scenario, that how it is going to interact with the system. As a mean of cooperation across the professional boundaries. So how the people are doing the cooperation across the different professional boundaries. Maybe there is an interaction between the marketing team, and there is an interaction between the IT department. So how they are going to be communicate, this has to be described using the scenario. Plus and minus scenarios to be explore the extreme cases. So some scenarios may have some benefits, but they may also have some disadvantages, so these have to be evaluated and then come up with the right solution. So when you are creating the scenarios, when you are generating the storyboard from the scenarios, you have to draw some sketches. They can be on the paper or they can be on the software. So usually you are using some icons or some symbols. Usually if you are using a software, which is more common practice, then the templates are available there, which are going to be used to draw these storyboards. And as I told you that either we can draw the storyboard or the scenarios on the paper, or we can use the card based approach. Now explore the user experience. So once we are exploring the user experience, we have to use the personas, the card based prototype, or the sticky to model the user experience, how the user is using the system. We have to explore this experience. So this can be done by the personas. As I told in one of the earlier lectures, that personas are some character. They may not be exist in the real, but they are demonstrating or they are representing the specific kind of the users. So we can explore the user experience by the design map, by the customer user journey map, or by the experience map. So the two common representation which are used to explore the user experience are the wheel and the timeline. In case for the wheel, we are exploring the user experience by using a wheel, in which we can describe the different stages in the different part of the wheel. For example, if a user is going to travel, then we can categorize his traveling experience by using the wheel, and in this wheel we can have the three parts are there. Something user have to do before the traveling. So maybe we can say this is like a first part. Something the user is going to experience or user have to do during the traveling. And then something user have to do after the traveling. So we have depicted, or we are trying to explore the user experience by the wheel. So we are moving in this direction. The user is going to experience or do something before the traveling, during the traveling, after the traveling. For example, if you are going to read this thing, you are going to read, let me discard this thing and again make it a little bigger. So you can see that before the traveling there are some steps are there. Contact the travel department, book the tickets. So when someone is traveling, he has to contact to the travel department, he has to make the reservation, he has to purchase the tickets are there. So these are steps are there before the traveling. And then during the traveling, if someone is traveling on the plane, then he has to board the plane, he have to follow the safety procedure. The plane is going to take off. During the traveling, he can sleep, or he can have a lunch or the dinner, and then these things. And then once the traveling is complete, then he is coming on the airport, then he has to collect the luggage, he go to the taxi and go to the destination. So the experience of the user is being modeled by using the wheel. The second approach is that we are trying to explore the user experience by the timeline, in which we have, you can think that we have a timeline from the left to the right, and in this timeline the different stages or the different sequence are there. For example, the first one is here, the second one is there, the third is there, and then fourth, and then fifth, and then sixth are there. So within the each time frame there can be the multiple activities are there. There can be some steps can be there, there can be some questions can be there, there can be some comments are there. So we are trying to evaluate the user experience, or we are trying to explore the user experience in terms of the time which is moving from the left to the right. So these activities are done in the sequence, but we are arranging them in the left to the right. And within each step there can be the multiple things can be there, some questions can be there, some comments can be there. So we are trying to model the experience of the user by using the timeline kind of map. Now the next thing is that constructing the prototype, making the prototype. So there are different mechanism are there. Maybe if we are talking about the software, this is very simple. You want to build the prototype, you can use some language, for example maybe the Python, maybe the Java. You are building the GUI which is not fully functional, but you can show to the final user to build the prototype. But this might not be possible in every case. Maybe the thing we are working on, the product, is not something like a software. This can be a different, so the different possible toolkits are there, different possibilities are there. Maybe the 3D printer or maybe some other kind of things are there which can be used to build the prototyping. So let's talk about these things: construction of the prototype by the physical computing, build and code the prototype using the electronics. Toolkits are available. So there are electronic toolkits are available which can be built to prototype, for example Arduino, LilyPad for the fabric, Sense keyboard, and Makey designed for use by the wide range of the people. So let's see some of these things. I think I have some videos are there. So it is the LilyPad using the Arduino. So here you can see that they are using the electronics, and they are building or they are constructing the fabric, and the electronic components are being attached or being accommodated in the fabrics. So we are going to little more faster. So they are sewing these components into the fabric. So they can be different kind of sensors can be there. For example, there are the sensors are there which are measuring the temperature or the humidity or maybe some other things about of the user when the user is using these fabrics. And these electronic components can be programmed. So we have some softwares are there which are using to control these components. So this is the example for the Arduino LilyPad, and let's see if I have some other example. 3D printer, I show you testing the sensor on the sense mode. So they are using some sensors. So they are putting the cable on some device, and the output is going to be shown on the screen, and they can control, they can configure. So they can control or they can test the sensor by using this thing. So these are some examples are there how we can use the construction by using the physical computing. More detail about there here. For example, we write here the LilyPad. Some details are there about the LilyPad. LilyPad is a set of several electronic pieces designed to help you build a soft interactive textile, a clothing or fabric. A set of several electronic modules including a small programmable computer called a LilyPad Arduino can be stitched together with conductive thread to create an interactive garment and the accessories. LilyPad can send the information about the environment, as I told you, maybe the temperature or something, using the sensor, using the input like the light and the temperature sensor, and can act on the environment with the output like LED light, vibrator, motor, and the speaker. So maybe he can give the kind of information to the user that the temperature is increasing, maybe you have to drink the water or something like this thing. So this can be sewed into the fabric, and the user is getting the feedback interactively from this thing. So this Arduino board is there, and there are some Makey toolkits are there which are also used to build some kind of circuits. So these people, you can see that they are using this Makey toolkit, and they are attaching with the fruits. So I think that they are measuring some kind of electricity or something like this from the fruits. Now the most easiest thing for us is the using the software development kit for building the prototype. Software development kits, for example the Java or maybe other things, can be built to build the prototype. Programmable tool and component to develop for the specific platform. For example iOS, we can use some toolkits or some development kit to build the software for the Android, for the Apple iOS, or for the other platform. Include the ID, documentation, driver, sample code, application programming interface are there. So once you are using the software, so you have the integrated development environment is there. For example, we are using the NetBeans, then the Java documentation is available there. If we are interacting with the other devices, driver softwares are required there, and the complete help is available in terms of the application programming interface. Make the development much easier. And the Microsoft Kinect SDK has been used in the research. So Microsoft has developed the SDK or the software development kit for the Kinect. Kinect is a device which is being used with the Microsoft Xbox, and the user can use the device to interact with the Xbox and to play the game. So the user's actions are being observed or monitored by the Kinect, which has sensors are there, there is a camera is there. So the user movements are being captured, and then the user can use his movement to control the game. Let's come to the summary of this lecture. Different kind of prototype are used for the different purpose and at different stages. Prototype answer the question about the design about the product. The final product must be engineered appropriately. So we know that in the prototyping we have to do some compromises, maybe the vertical compromises or the horizontal compromises. So this should not be appear in the final product. So we have to develop the final product which does not have any compromises. Two aspects of the designs are there: conceptual and the concrete design. In the conceptual design, we have to identify that what are the interaction types are there, what are the interface types are there. Then based on this thing, we are developing the concrete design. To generate the conceptual design, consider interface metaphor, interaction type, and the interfaces type. A storyboard can be generated from the scenarios. Card-based prototype can be generated from the use cases. So in many systems we have the multiple use cases are there, how the users are using or interacting with the system. So a card can represent a use case. Physical computing kits are there which can use the Arduino or the LilyPad to attach or to sew the electronic component or the sensor with the garments, or we can use the software development kit to construct the prototype like a Java SDK or maybe the DirectX or some other thing for developing the game for the different platform, for the iOS, for the Android, or for the Windows. So this is the end of the lecture. Some references are there, some disclaimer, and the fair user statements are there. So thank you for listening this lecture.